but that's the one that could detect quickly. So let's see this test. I don't want to hear anything about convergence regarding this, right? If it diverges, it diverges. If the limit is 0, it can go either way. So we'll see about that. So here we go. An example. Summation of 3n plus 1 going from 0 to infinity. You just go limit 3n plus 1 as n goes to infinity is equal to infinity, not 0, diverges by divergence test. Done. That's all it is. Nothing fancy, nothing special. Summation of 3 times 4/3 to the n when it goes from 0 to infinity. What do we know about this? By geometric, right? Yeah. Excellent. Limit 3 times 4/3 to the n is going to be infinity, not 0. It can also diverge by divergence test. Also diverge by geometric test. Great. Summation of 1 plus 1 over n to the n going from 0 to infinity. We have to check, right? Limit of 1 plus 1 over n to the n as n goes to infinity. Nope. This is equal to what?
1.
No. E. Yes. Not 0. Diverges by divergence test. There's so much lag that it's just... Summation of n factorial divided by 3 to the n, 0 to infinity. Summation of n factorial divided by 3 to the n. We don't know how to take the limit of n factorial, but we know something else that I mentioned last class at the end. Yeah, I talk a lot, I know. What did I say at the end of the last class? There we go. I said fast over slow equals infinity, right? N factorial grows faster than exponential functions. And when you have the limit go to infinity, which is all of your limits for series are going to infinity, it's fast over slow, it's infinity, it's not 0, diverges by divergence test or n-term test, whatever we're going to call it. Oops, can't start at 0, right? Had to start at 1. or 2 or can start at 0. 1 over 0 is... Now, why do I call this the evil one? Exactly. Inconclusive. That's the answer. Limit n goes to infinity of 1 over n equals 0. Test is inconclusive. Use something else. And that something else is going to be integral test on Monday. Okay? This one over here is called harmonic series. We will discover that it's divergent, but this test did not detect that. And it has a special name because it's very, it's used a lot, and it does a lot for our application problems. It has a special name. It's called harmonic series, and it's divergent. It doesn't add to a finite number, even though it's 1 plus 1/2 plus 1/3 plus 1/4. They simply are not falling to 0 fast enough for them to converge. We will see other examples that are similar to harmonic series. So harmonic series are divergent, and the proof for this will be done next class using integral test. And they also belong to P series, so you will have a lot of other ways to deal with harmonic series. Right now, the only thing you can say is test is inconclusive, i.e. you have no clue, right? Because none of the tests that we learned so far, we only covered 3 out of 10, right? So none of the tests would actually work on this. So integral and P series are the next 2 tests we're going to cover, and they will both take care of this. Then we have alternating harmonic series, and those will be in 10.6 when we do alternating series. Then we're going to even build more on top of this. So right now, you can. Do you see the danger if you are to say, oh, equals to 0 converges? Hell no, right? You cannot say converges by divergence. Please make that, make that ridiculous statement make sense, right? So you can only claim divergence by divergence test. So that's it for tonight. Yes?
Could you use like the case substitution thing for this?
Nope.
Okay.
You'll see the integral test. We're going to take care of it very easy. Yep. All right, so that's it. We'll continue.